Python floating point number comparison. I'm just reviewing some basics of Python, and there's a tricky problem about comparing floating point numbers. Please help me here. Thanks.
This might be illuminating. Although they are all displayed in decimal as 6.6, when you inspect the internal representation, two of them are represented in the same way, while one of them is not.
In order to complete Amidon's good answer, here is a more obvious way of seeing that 2.2 by 3 and 3.3 by 2 are not represented by the same float in a Python shell. In fact, the Python shell displays the representation of numbers, which by definition should allow the corresponding float to be correctly built back from the representation, so you see the numerical approximation of 2.2 by 3 that Python does. The fact that 2.2 by 3 not equal 3.3 by 2 is obvious when seeing all the necessary digits, like above.
It is also obvious that 3.3 by 2.0 is numerically identical to 6.6. The latter computation is nothing more than an increment of the binary exponent, as it is the result of a multiplication with a power of 2. You can see this in the following. Above you see the binary representation of the floating point numbers 3.3 and 6.6. The only difference in the two numbers is the exponent, since they are only multiplied with 2. We know that IEEE 754 will approximate a decimal number with the smallest numerical error, can represent all integers up to 2 to the power of 53 exactly, for binary 64. So since 2.0 is exactly representable, a multiplication with this number will be nothing more than a change in the exponent. So all the following will create the same floating point numbers. Does this mean that 2.2 by 3.0 is different from 6.6 because of the significant? No, this was just due to rounding errors in the multiplication. An example where it would have worked would have been 5.5 by 2.0 equals 2.2 by 5.0 equals 11.0. Here the rounding was favorable.
If you want to support the channel, please consider liking and subscribing.